Okay, so in this video, we're going to look at division and multiplication when we're dealing with radicals. So this one we have here is a division one. Let's kind of come over here and write some notes down first. When you're dividing with radicals, so here we have the cube root, let's just say x over y. That can always be rewritten as the cube root of x over the cube root of y. Many people forget that equal signs go in both directions. That means, say that I was given the square root of x over the square root of y, I know that I could rewrite that as the square root of x over y. So this becomes useful because sometimes it is easier to just go ahead and simplify the radical in the numerator and the denominator the way it is. Sometimes it's more useful to simplify the fraction that is given to you and then go ahead and do the radical on the top and bottom. So those are the ways that we're going to do division with radicals. Is at some point you're going to do the radical of the top and the bottom, and then you can get it back again and simplify what's left over, or if you need to simplify what's on the inside and then take the radical. So it goes either way. So if we come back and look at this one then, there are two different ways that I could do this. The very first thing I'm going to check is, I like to check in the middle, is there anything that reduces? Well, 8 and 27 don't have any common factors. Y is just in the top, x is just in the bottom. So there isn't actually anything that could simplify here. If there was, I honestly like to simplify that first. Because there's nothing that simplifies, I can rewrite this as the cube root of 8y to the fourth over the cube root of 27x cubed. Just like we've done before, we're just going to simplify this. Immediately off the top of my head, I know the cube root of 8 is 2, because we can multiply 2 3 times to get 8. And then, just like we've done with the other ones, it's going to be y 4 to the 3. So that gives me y. If I divide those, it's y to the 1. And then there's a remainder of 1. So the y to the 1 comes to the outside. The remainder 1 stays inside. In the denominator then, if we look at the denominator, same thing, 27, you might not be sure, so you can break it down to 3 and 9, 3 and 3, and I see that I have a 3 cubed, so that 3 goes to the front. The x would become x, 3 divided by 3, which is just 1, so that x comes out to the front. And there you have it. So notice the big thing here was we took this big cube root, and we said that applies to the numerator and to the denominator. We took the cube root of everything on the inside of it. The other thing we can do then is multiplication. So the big thing that we need to recognize here is that when we're multiplying, it doesn't really matter the order. So we typically write it as a coefficient and a radical times a coefficient and a radical. But I could rewrite this as 2 times 4 times root 3 times root 5. When we do that, you can see that we can immediately go ahead and multiply those coefficients. 2 times 4, which is going to give me 8. But then on the inside, it's like, okay, what do I do here? What do I do here? The really cool thing is we can actually, as long as it has the same index, and that is really important, as long as it has the same index, you can actually multiply these together as well. So this would become the square root of 15. So when you're multiplying radicals with same index, 1, you can multiply the coefficients, and then 2, multiply radicands. And the really cool thing is then 3, if you can actually simplify the radicand, which would be simplifying the radical, but you'd be breaking down the radicand. So let's see what that looks like for another example. First thing I said, multiply those coefficients. So we're going to do 3 times 12, which is 36. Then multiply the radicands. This one will give me the square root of 8 times 7, which is 56. Now we need to see, does 56 break down? So the really cool thing is I know that was actually just 8 and 7. 8, we know is 2, 2, 2. I'm looking for something, my index is 2, so I'm looking for things I pair twice, it brings it out to the front with that 36. So 36 times 2, I'm going to keep my radical. What's left over is 2 times 7. So my final answer here then would be 36 times 2, which is 72, times 2 times 7, which is 14. And there you have it, some very basic operations with radicals.